Welcome everyone to today's Explainer. If you're an 8th grader ready to unlock the secrets of the universe, well, you are exactly where you need to be. Today, we're going on this really fascinating journey into the invisible chemical makeup of our world. We're going to look closely at things you interact with every single day, but from a completely new, kind of hidden perspective. Get ready to see the unseen.
Okay, let's dive right into this. Have you ever looked at a glass of tap water and a glass of white vinegar sitting side by side? To our human eyes, they look exactly the same, just two glasses of clear liquid. But chemically, they are wildly different. One is totally neutral, and the other is an acid. The massive problem scientists face is that these chemical reactions and properties are largely invisible to our naked eyes. So, how do we actually solve this? How do we see what's invisible? I love how Proverbs 20:12 frames this whole idea. It says, "The hearing ear and the seeing eye, the Lord has made them both." God gave us our natural physical senses to understand, navigate, and really appreciate the world around us. We can see a beautiful sunset, right? We hear a bird sing. But as scientists, we have to go a step further. We use specialized, brilliant scientific tools to literally extend those God-given senses, allowing us to measure and understand this chemical world we simply cannot see on our own.
Section 1. Why measuring pH matters.
So you might be wondering, why do we even care about measuring this invisible chemistry? Is this just boring lab work that stays stuck in a classroom? Absolutely not. Understanding and measuring acidity and basicity, what we call the pH level, is absolutely crucial to keeping our daily lives functioning and honestly keeping us safe. Just look at this list. This is your everyday life right here. Measuring pH ensures the food you eat is safe and won't make you sick. It maintains healthy ecosystems so fish and wildlife can actually thrive in lakes and rivers. Have you ever jumped into a swimming pool and had your eyes immediately start burning and turning red? Yeah, that's because the pH was unbalanced. And out in the fields, farmers are constantly checking the pH of their soil, because if the dirt is too acidic or too basic, entire crops of food will just wither and die.
Section 2. Tools to measure pH.
Let's move to our tools. Now that we know why it's so incredibly important, it's time to look at the scientific superpowers we use to reveal this hidden world of acids and bases. How do we actually pull this off? Well, we have a few amazing tools in our scientific toolkit. Our first hero tool is called an indicator. An indicator is simply a substance that changes color depending on whether it touches an acid or a base. Think of it as a direct visual translator. It basically speaks the complex language of chemistry and translates it into a language our eyes can easily understand: colors.
The most famous indicator you'll probably use in the lab is litmus paper. It's a quick, stark contrast that tells you exactly what you're dealing with. If you dip a piece of litmus paper into a liquid and it turns red, boom, you've got an acid. If it turns blue, you're dealing with a base. It's an instant, binary answer. Red for acid, blue for base. Super simple.
But sometimes we need to know a little more than just acid or base, right? We need to know exactly how acidic or how basic something is. That's where the universal indicator comes in. This brilliant tool levels up our measurement by providing a wider spectrum of colors. It's kind of like a chemical rainbow. It gives you a whole range to judge the exact pH level, shifting through yellows and greens all the way to deep, dark purples.
Now here's the thing, sometimes colors just aren't enough. Your eyes might play tricks on you, or hey, you might be colorblind. That's when we bring in the heavy machinery, the digital pH meter. Instead of making us guess a color match against a printed chart, a digital meter gives us exact, pinpoint precision, often displaying a number to one or more decimal places, like 7.1.
And this totally illustrates how scientists think. We choose our tools based on the specific problem at hand. If you're a pool cleaner making sure the water is generally safe, a quick paper strip indicator is incredibly fast and totally fine for the job. But if you're a scientist in a laboratory creating a life-saving medicine where a tiny fraction of a pH point matters, no way you're using paper. You are reaching for that highly precise digital meter every single time.
Section 3. Quick pH Knowledge Check.
All right, you've absorbed a lot of fantastic information. Now it's time for a rapid-fire training ground pop quiz. Let's test what you've just learned and lock this knowledge in for good. I'm going to ask a question, and I want you to shout the answer out before I reveal it. Ready? Let's go. Question 1. Name 2 distinct ways or tools we use to measure pH. Think back to the superpowers we just discussed. I'll give you a second. Got it?
The answers are indicators, like litmus or universal paper, and digital pH meters. If you got both of those, excellent job. You're already thinking like a chemist.
Question 2, and let's keep the energy high. What color does red litmus paper turn when you dip it into a base?
Blue. Remember the mnemonic, base equals blue. They both start with the letter B. Fantastic. Moving on, let's do a combo question for numbers 3 and 4. What exactly does a digital pH meter display, and why is it considered vastly more accurate than using paper indicators?
It displays a precise digital number. The whole reason it's so much better for lab work is that it completely removes human error. There's no guessing if the paper is yellowish green or greenish yellow. The machine just literally tells you it's a 6.8. No guesswork allowed.
Final quiz question, number 5. Let's ground this science back into reality for a second. Give me one real-world situation where measuring pH is absolutely critical.
If you said testing pool water, checking farming soil, ensuring safe food production, or protecting our natural ecosystems, you nails it. This isn't just trivia, guys. This knowledge has practical power in our everyday lives to keep humanity healthy and thriving.
Section 4. Education, Morality, and Peace.
Now I want to take everything we've talked about and look at it through a slightly wider lens. We're going to pivot to the overarching philosophy of the heroesmartacademy Godly Learner series. We spent the last few minutes talking about physical tools to measure our physical world. But what about the tools for our mind and our character? Think about this powerful statement. Education without morality will hurt. Just as a pH meter keeps our physical world safe from dangerous, unbalanced chemicals, biblical morality is the tool we really must intertwine with our education. Think about it. What is the point of being incredibly smart, having all this scientific knowledge, if you continue to make bad, unguided choices that hurt yourself and others? Knowledge without a moral compass is, well, it's dangerous.
True mastery requires both a sharp mind and a grounded spirit. The source points us beautifully to Romans 8:6-7, which promises peace of mind to everyone who keeps their mind spiritual. Just as we use precise tools to find balance in chemistry, keeping our minds focused spiritually gives us balance and peace in our daily lives. This is the ultimate goal of true education.
And that brings us to the end of our explainer today. I want to leave you with this final, vital question to think about. You now understand the tools needed to measure the physical world. You understand pH, indicators, and meters, but how will you use your own morality to guide your daily choices? How will you use what you learn to bring peace and balance into the world? Think on that today. Keep learning, keep growing, and I will see you on our next explainer.